In April 1912, the RMS Titanic sank, resulting in the deaths of over 1,500 people. The loss of the ship was the direct result of compounding operational failures and strict design limitations, rather than a single unavoidable collision with an iceberg. The subsequent investigations into these failures forced a complete overhaul of global maritime law, establishing the mandatory safety infrastructure that every merchant and passenger vessel relies on today. Built in Belfast under the ownership of American financier J.P. Morgan, the Titanic measured 883 feet from stern to bow. This animated cross-section details the hull design that earned the ship its reputation as unsinkable. The lower structure was divided into 16 watertight compartments, specifically engineered to keep the vessel afloat even if up to 4 of them flooded entirely. On April 10th, the ship departed on its maiden voyage with 2,200 passengers and crew. While leaving port, the Titanic's immense displacement created a water surge, snapping the mooring lines of the steamer New York and narrowly avoiding a collision. This timeline lists the 7 separate messages warning of drifting pack ice received by the ship's wireless operators between April 12th and April 14th. Despite these documented alerts, the Titanic maintained an unsafe speed of roughly 22 knots into the night. At the time, major shipping lines prioritized strict schedules and treated hazard reports as mere advisories. Navigational caution gave way to corporate momentum, leaving the crew unprepared for the ice field directly in their path. The ocean on the night of April 14th was glass-like and perfectly calm, removing the breaking waves that normally make icebergs visible. In the pitch dark, at 23:39, lookouts finally spotted a mass of ice right ahead. At 23:40, the ship suffered a glancing starboard blow. The impact buckled the hull, exposing 6 forward compartments, 2 more than the design limit. Because the bulkheads were not capped at the ceiling, the ocean poured over the top of each, flooding every successive section. The compounding weight levered the stern vertically out of the water. At exactly 02:20, the extreme structural stress snapped the vessel in half, and it plunged to the ocean floor. The failure of the internal bulkhead design guaranteed the ship would founder, and a shortage of lifeboats left the remaining passengers with no means of escape. The RMS Carpathia arrived hours later, rescuing 710 survivors by 09:15 that morning. Another vessel, the SS Californian, had been less than 20 miles away, but missed the distress calls because its sole radio operator was off duty. Those left in the water faced air temperatures near freezing. Over 1,500 people died, the vast majority succumbing rapidly to cold shock and hypothermia rather than drowning. Survivor testimonies clarify the final hours on the bridge. Captain Edward Smith calmly directed the evacuation to mitigate panic, and First Officer William Murdoch signaled the engine room to stop, directly contradicting dramatized accounts that he threw the ship into full reverse. Stripping away cinematic dramatization allows us to analyze the verified survivor testimonies and physical evidence, revealing exactly how the engineering and command systems failed. This timeline charts the immediate regulatory aftermath. Congressional and British inquiries directly catalyzed the 1914 International Convention for the Safety of Life at Sea. The disaster also spurred the U.S. Coast and Geodetic Survey to develop radio-acoustic ranging, the foundational technology for modern sonar mapping. The physical wreck remains 12,000 feet below the North Atlantic. But the strict legislative mandates and maritime technologies extracted from its loss continue to protect every merchant vessel operating today.